been here for the first two in this lecture series, thanks for being back. For those of you who have not been here for our first two, this lecture series has really been framed around two keywords, shelter and pedagogy, and we are sort of going back to the fundamentals and the basics of material, of building, and sort of asking our guests to rethink and revisit the idea of what architecture is in relation to those components in terms of construction and building practices. So without further ado, I am going to hand it over to Randy, our program chair, to introduce our guest, and then enjoy.
Welcome. We're excited to have Jonathan here. For those of you who did design build last year, we know Jonathan. We visited him in Portland and got a great, I think we're going to get a little bit of that for this lecture, a little refresher. But we visited him. Jonathan is the principal at Lever Architects in Portland. And I'm going to read something here for a second. We'll be off script here for a moment. And just say that, you know, Lever, I think, came up, you know, relatively recently in the Portland architecture scene, but is, you know, one of the firms that started, I think, after Allied Works as being kind of one of the primary really good design firms in Portland. I think Lever was one of the first that sort of came up behind them. And I think you said you worked at Allied, right? Yeah, so Ben, who was here before, worked at Allied, Jonathan worked at Allied, and so I think there's a nice kind of continuity there, and again, a great sort of inventiveness, while also kind of intense sort of attention to the details, which I'm sure we'll get a lot of today. Jonathan also, we were just comparing notes while we were at the office. We were like, oh, we both went to the University of Oregon, but then we didn't also compare the note that I grew up in Oregon and he grew up in Oregon, and so when I'm asking specific questions about where he lives, he's like, why would you want to know? I know these places. So, in any case, unlike, as I related to you with Ben, that we did not play football against each other, to our knowledge. But other than that, though, you know, Jonathan gave us a great, hosted us a great sort of tour and lecture. Lectures are probably not quite the right word, sitting around a table in their office, but nonetheless, a really good talk about their work, and I'm eager to see what he has for us today. So Jonathan is a principal at Lever Architects with 20 years of design and management experience working with significant civic and creative organizations. Born and raised in Oregon, as you know, Jonathan's formative experiences are in the forests of the Pacific Northwest and led to a commitment to timber construction and its benefits for regional ecosystems and societal health. His experience in timber led to his management role on Framework, the first mass timber high-rise project in the U.S. to receive permitted approval in 2017. Jonathan directs Lever's research and testing work, a grant-funded initiative encompassing more than 50 mass timber studies on topics ranging from full-scale seismic, structural, and acoustic testing of wood assemblies to indoor air and thermal comfort analysis of mass timber buildings. He's currently working on a design for his alma mater at the University of Oregon, the Acoustic Testing Lab. He's also working at Oregon State University's Fire Testing Laboratory and Timber Lab CLT manufacturing facility to advance the utilization of mass timber. So with that, let's all give a warm welcome to Jonathan Heppner.
Thank you for the introduction. I'm really excited to be here. I am a little bit chained to the podium, so I may start wandering off and miss slides. I had a really hard time preparing for this, mainly because I'm extremely excited about wood, which seems a little passé maybe or boring. But I put together a few of the slides around our work, and I'm going to share with you why I'm really excited about wood, and this is my passion and why I'm interested in it, and hopefully you can come away with something that makes you feel a little bit more connected to the people around you and in the environment that you're in, and maybe inspired, hopefully. Don't want to stretch too far. We also have offices in Portland and Los Angeles, and Los Angeles is a new endeavor for us. We're starting to do timber work around the country, and I was really excited. Every couple months I update this map, and what's interesting for me is that as an Oregonian focused really on wood construction, that all of a sudden wood is spreading and wood construction is a new endeavor that's really showing up all across the country, and people are seeking us out all across the country to do projects, specifically in mass timber. So what I wanted to talk about a little bit, aside from just giving you a quick sample, these are some of the buildings that we've done that are complete this year, and I'll go into a few of these maybe at the end of the discussion. And these are a group that we have that are all in design right now and in permitting. So our office probably has 30 people, and right now we're completely overwhelmed with the exciting work that we're doing. But I'm going to share a little bit of the research with you, and then share a little bit of how that research ends up folding back into our projects. But before that, I wanted to talk a little bit about the forest, because I was joking with other people earlier that I was raised by trees, and the more I would say that, and it was kind of a tongue-in-cheek thing, like, ha ha ha. And then the more I started thinking about it in little quiet moments on an airplane or in a car or whatever, I was like, actually, really, everything that I'm involved with somehow ties back to this initial memory or experience or something about the forest, and it made me realize how intricately interwoven all of our experiences are with products that are made from wood and just the forest itself. So I grew up really interested in drawing and sketching, and was fascinated by this book, D.C. Beard, where it was really, I think this is potentially the founder of the Boy Scouts. There were all these little sketches and different diagrams about how you could put together buildings. And for me, what was so immediately applicable for this is I lived pretty close to a small forest, and I could just go out and look at these diagrams and start fiddling around with it in an afternoon, steal my dad's saw or whatever, and end up being able to build little structures, and it created this interest in the forest. As I got older, found that I could go to this really interesting camp in the Stanislaus National Forest outside of the Oregon coast. And I wasn't around when this building was built, but what was unique about it is that the U.S. Forest Service provided a land lease so that campers in this camp could grow up. And so every summer I would go out to the forest and spend time in the woods, just hanging out. And I think this, to me, brings something full circle, which is this idea about community and the idea of being out in a place with people or just in a room with people, and the ability to share ideas and how that will then translate back into our work. So that theme will probably come back around as I'm talking about our projects. So before we talk about mass timber, I wanted to talk a little bit about the way that timber was used historically, I guess, in the early 1900s for construction. I find it fascinating that somebody walked into the woods at some point and there was a tree that was this scale, and they imagined cutting it down. There was this immense abundance of resources in the West, and that abundance led to a lot of really beautiful buildings and this advancement of hand technology and construction technology that I guess you probably wouldn't call it technology in the 1900s, but this idea that you could build structures that would last out of this material that was just right outside your door. So in Oregon, there was an expo in 1905, and the state wanted to show off all the amazing things that it could do with wood, and so they built the world's largest wood cabin, which survived up until the 1960s, and ironically burned down because of an electrical fire. But the construction methodology that they used for this was really just like, I'm going to cut the tree down, and then I'm going to tilt up the log with the bark on it, and create a cathedral that's much like a forest so that people can go and walk through and see how amazing this kind of resource is. So it's so basic that the shape of the tree, the scale of the tree, everything about it, all you had to do is really figure out how to cut it down and tip it up. And it kind of shows this interesting orientation towards building, and the first thoughts of like thinking back about the diagrams in the book that I was looking at, just at a much larger scale. So as technology and this availability of lumber was more readily known, there was a lot of transportation. The railroad systems were completed to connect to the west, and immediately you started seeing that it was inexpensive, or it was cost prohibitive to haul really large things, and so you'd start to see smaller and smaller increments of that large thing shipped around the country, made into homes, made into ships, and the idea about what you could do with a smaller scale piece of that larger material started to develop, and is continuing to develop today, which is now the primary focus of what I spend the vast majority of my time working on. I think the other thing is that, speaking of the abundance, at some point, this is an image from the 1930s in Idaho, where logs would float down the river, and I don't know if any of us have seen this in our lifetimes at this point, unless it's like maybe in Canada somewhere. But this no longer occurs, and there was so much forestry happening and so much of the material coming out of the forest, there wasn't maybe a lot of consideration about how long it would last or what the implications of its use were. And today we find ourselves in a slightly different scenario where there is an abundance of forest still, but there's also a lot of environmental issues that come from extraction of the wood from the forest that cause me to think about my use of that material. There's also a lot of construction emissions that are affected, not from wood specifically, but just from concrete. And I've been startled to always look annually at like how much global concrete has been used this year, and what the kind of use of that material implies for our world. Also, with forest fires, for instance, the amount of carbon that just a fire of a single forest can release. I think what's interesting about this discussion around wood is that as an architect and a research architect, I find it really fascinating. Is there some way that I can use or think about the material that has a positive impact that will help people either have an elevated experience or just that there's some meaningful value in the work that I'm doing that improves people's lives? So I don't know if this is widely known. I feel like I see this a lot, but our buildings produced, and the construction industry, over 30, kind of up to 40% of the emissions annually. And so the work that we're doing in construction has a direct impact on air quality, water quality, animal habitat, etc. And so I continue to think, well, what does the relationship that I have with the forest mean, and what can I start to do in my practice that will have a more positive impact on that? So about in 2017, we started looking at this idea of forest to frame with some of our projects, and really started doing something that for me was unique in my practice, which was looking upstream of where I was designing to start making relationships and learning more about who was cutting down the trees, who was actually fabricating the trees, what were their concerns, what were their interests, and at each step of that process, I started to realize that I was a part of a much larger chain, and that my typical purview as an architect was really that I would talk to somebody who had already produced a material, and I would work with somebody that wanted to build something with that material, and I would be conceiving of a design with a team of people to take that product and build something. And in the discussions that we were having, it made us realize that we needed to expand that discussion and interaction with the people that were actually milling the material, cutting down the logs, growing the trees in the forest, so that we could understand a little bit more about the material that we were working with. So that led us into our work with mass timber, and I think I won't go deeply into this because I'm sure that most of you know and understand what mass timber is, but at a molecular level or a cellular level, wood is an incredibly unique technology, I'll call it. It has amazing compressive force, and it sucks up water, and it also sucks up nutrients, and it captures carbon, and it has all these amazing things that it's doing. And because of its scarcity, I guess you could say, or the cost of moving large pieces around, cross-laminated timber, glue-laminated timber, dow-laminated timber, all of these different, what I would classify as mass timber products were developed with the use of adhesive to start putting together smaller pieces of wood into structural materials. And in 2015, we had the opportunity in Oregon to participate in the first cross-laminated timber panel that was coming off of a press and conceive of a building that used this panel. Interestingly, this wasn't a new idea. Cross-laminated timber it was patented actually as an idea in 1923 in Tacoma, Washington. And probably the reason that patent really didn't go very far in 1923 is because there were plenty of really large trees that people could build with. So moving to the current day, the benefits that we can see is that it has an incredible strength to weight ratio, it's fire resistant, it's fast to construct with, it's clean comparatively to doing lots of dirty concrete work. The construction is fast and quiet, and it also has all of this ability to sequester carbon, and depending on how you think about where it's coming from, positively impact issues around wildfire, etc. So in 2014, we started the design on what's now our office building that I think some of you visited in Albina district in Northeast Portland. And really, there wasn't much of a stretch here for us. What we were trying to do is just take the material and knowing that other people were going to be building with it, like just don't mess it up. Just do a good building and keep it straightforward. And so the system that we conceived of seems really extremely complicated now in retrospect looking at it, but we were basically dealing with a 4-post typical construction with a CLT deck that was 3-ply, and then we were using a steel component to basically create this connection. And most of the building details used this one detail, so we tried to just come up with a simple detail that we could repeat over and over again. And the way that ended up shaking out after we produced the construction documents and went through the shop drawing process is that we had to work with somebody that we hadn't worked with before, which is the fabricator who is going to be actually cutting the design that we had put into the SketchUp model and the Rhino model that we were working with. And as we started to work with it, we realized all of a sudden that most of the details that we had drawn didn't really work that well. And so we ended up going through this really exciting design build kind of process, I guess you could call it, where we were doing mock-ups to test the material. And in this case, we realized, for instance, that the CNC fabrication was so precise that we had to account for the welds in the steel. And there would have been no way to know that unless we had actually put the two things together and built it in place to test it. And the building turned out really excitingly. It turned out great. Construction was very quick, so we could bring the materials up. The CLT panels would come up from outside of Eugene in about 3 hours, and they would arrive around 9 in the morning, and then by lunch, a team of like 3 or 4 people would put down 4,000 square feet of floor deck and then get the walls and the columns tilted up and prep for the next floor, which would take another week or so to build. And the level of resolution, or the material, was absolutely beautiful. And as you can see in this other picture, we didn't really consider, we knew that we were going to be building in the rain, but we didn't quite realize that this was going to be open and in the rain for probably 6 months to 7 months. And as it turned out, the wood was able to support construction in the full rain, and if you've been to the building or have a chance to visit, you could never tell that it was exposed to that during that time. So what was exciting about it for us, though, too, is that we started to realize this idea that there was this connection, and especially when you went up on the top floor on the job site, that you realized, like, oh, the building that I'm standing on right now is produced from the forest that I can see in the distance. And there was a direct one-to-one correlation that was very present and impactful. So around the same time, there was a competition for a tall wood building that was mentioned in 2017. And there was a lot of emphasis on the use of mass timber. It was a national competition. We won the competition with Shop Architects also winning a version of it in New York. And our two firms were going to design in Portland, Lever was going to design a 12-story building that was for affordable housing and a B Corps office. And then in New York, they were going to design luxury condos, so high-rise, gives you any indication of the different, found that interesting. But for the competition, we developed this idea that for this material to be successful, we would need to be thinking about the forests that the materials came from and how that went to the mill, and this idea of this, what we call the virtuous cycle, where rural economies and urban economies were joined, and that we were doing a lot of things all at once just through the use of this one material. And interestingly now, as I look, and this was now about 7 years ago, when I start to look at the work that we're doing, all of these little jobs, forestry jobs, the manufacturing jobs, new projects, code acceptance, transfer of technology, we were just making this up at the time, and what's exciting for me is that all of the things that we were talking about in this diagram and hopefully seeing the opportunities for have started to take shape, and now in 2024 are happening. The unique thing about this building, Portland is in the high seismic area, and so we had to go through a lot of testing, and the grants that we got for the project were really about the testing of the material. We didn't, the jurisdictions that were approving it, which in this case was the state of Oregon, didn't know that it was fire resistant. There was no method or model necessarily, so we had to show through testing that the building was fire resistant. Structurally, we were in a high seismic zone, and there was not really an idea whether the building structurally at that scale would work, so we had to do structural testing. And then there were no current standards for mass timber and floor assemblies and acoustics, so a part of the building code is that we had to do acoustic testing so that we could indicate that when your neighbor's upstairs going nuts, that the code level floor would make sure that you were comfortable in the unit below. And I think this was really the point in the firm where there was a small fork, and we realized that we needed to be, if we were going to be serious about building with mass timber, along with knowing with the forest, we also really wanted to be involved in the testing. And so we started talking with Oregon State University, University of Oregon, any group that was doing mass timber testing, and would work with them along with our practice in architecture to start trying to get things approved and get money from grants so that we could spend some of our work testing products to use in buildings. In the meantime, the framework project was able to get through permit, which it was the first permitted mass timber high-rise, and that permit allowed the building code officials in Oregon and a large group of people nationally to start feeling comfortable about how mass timber might be adopted into the building code. And so this contributed to what is now codified in Oregon and other states around the country. So we started out, we always have the fir tree up for reference. We started out with the small, what we'll call a type 5, which is an all-wood small building, and then we did framework, and framework didn't get built. And then what was interesting is that in Milwaukee, Wisconsin, there was an interest, a piece of land, and a company was able to put together a team. Some of the builders were from Portland, and they had knowledge of the framework project, and we talked with them, and some of the engineers, Thornton Tomasetti, were working on the project, and we started talking and sharing some information, and they used a little bit of the research that we had done to talk with the building officials in Milwaukee, and the Ascent Tower was completed, I think, 2 or 3 years ago now, at much higher than we had anticipated for framework at 27 stories. And I think they're now working on a building that's mass timber that's maybe 29 to 30. And Wisconsin's apparently really cool with timber, so. And then also, at the same time, we started working on a project called Sandy Pine here well, I say here in Portland. I'm not in Portland, I'm in Idaho, but in the US. So, as a part of these projects, testing of the seismic was a really important piece. And so we, in partnership with OSU, started working on, I don't know if that's gonna play here, a shake table test so the building could actually work and experience seismic forces and not have damage. This particular test led to the utilization and interest by the National Science Foundation for a much larger version of the same thing, because they thought, well, it's great that it works at 2 stories, but will it actually work at a much higher? Let's see here. Boy, how many times can you want to see the Shake Taste video? This is the danger of including videos into your presentations. I'm going to have to click out of here. Well, just go to the next slide. Video keeps on playing. Oh boy, kick you out all the way. Nice to know. So in 2017, along with Framework, we started working on, oh boy. This is why I was debating, like, should I do a video? No, maybe. Yeah. Just pick a spot here. I'll go back over to my backup deck, the non-video deck. Yeah, and we started working on a 10-story version of that shake table, so you guys are all going to have. And because we were only working with one material, one CLT manufacturer, quite a few other manufacturers were like, hey, well, if you're only going to get it tested for this one material, then that means that's the only product that's going to be used in our buildings. So the principal researchers started talking with quite a few other manufacturers, and what ended up happening was that they incorporated mass plywood panels, nail laminated panels, veneer laminated panels, glue laminated. It is kind of all the laminations and acronyms started to get out of control. But it did successfully result in a 12-story project, and the goal of this project was to basically indicate that you could build a building that would experience the world's largest earthquakes and not only not fall down, but it would not be damaged and be immediately occupiable or could maintain occupancy after the earthquake. And what was really amazing is that the testing table would kind of work in 3 dimensions, and they could run the test simulations of earthquakes from Tokyo, the Northridge earthquake in California, and the building was wildly successful. There was one piece of damage, which was a slight error that we had made in the detailing of a non-structural component. Oh, I unshared again. This is good. Good stuff. Love technology. It's our friend. Thank you for bearing with us here in this wild ride of somebody sharing a screen. Wait for it. All right. So the test was wildly successful, and the error in drywall was attributed to a miscalculation, and the building successfully weathered, I think, over 1,000 simulated earthquakes, and no damage. The benefit of the team and the reason that it worked was because we had communicated as a group, and granted this took 7 years, so there was a lot of communication. But it was people from the forest industry, people from lots of different universities, the US Forest Service, and quite a few different engineers. And it really reminded me just the fact that it really does take a lot of collaboration and community to think about things together and come up with solutions and not necessarily just protect your creative kind of IP. So we started, somebody during the kind of process for the shake table reached out to us in Oregon, and they said, we're going to design some mass plywood panels. I was going to show you the video of this, but I think I may not do that now because I don't want to have you weather another thing. But there was a John Yon installation that was happening at the Portland Art Museum, and John Yon was a well-known architect that worked with plywood quite some time ago, I think back in the 50s, maybe even a little bit earlier. And so as a part of that installation, we worked with this manufacturer to take a test of their panel, which had not been put out on the market yet, and do a little demonstration pavilion with it for the Portland Art Museum. And the interesting part of these panels is that they can be fabricated up to 10 feet or 11 feet wide and 48 feet long. And then I won't go into the kind of my own internal thought process about the differences between CLT and MPP, but there is one interesting thing. So CLT is like made from stacking boards on top of each other, layer over layer. And the boards are basically cut. So if you imagine that a tree is an accumulated, over time, it's just layers on layers on layers. So every year the tree gets larger and larger. A beam is cutting through that, or small dimensional lumber, you're just slicing through that. And the interesting thing for me about plywood is that you're literally unraveling time when you run the log through the machine that's creating the veneers. And so what you start to see is, in a weird way, geologic, where the piece of plywood itself is actually becoming stratas of time. And then I'll start talking about the project, because otherwise I'll get into my own head about how interesting that is, and where did that little piece of wood come from, and what was the weather like that year. So anyway, we used this as a demonstration for the product, and they left it out in the rain to see what would happen. And then they were like, that's really cool, so let's see how much cutting can you do with it, and we might want to get interested in that. So we went through and did a series of pavilions for the Mass Timber Conference over 3 years, where we would work with the manufacturer to just basically test out what different ideas they would have and start to create these little test buildings, we called them, that would become a center focus at the Mass Timber Conference. And the final year, we're like, well, we should do one where we're just using the smallest 2-inch material that you have and see how much material we can get out of one piece of wood, and start what's the least amount of material that we can do to create a form. And it was just this really amazing opportunity to mess around a little bit with digital technology and fabrication. And then the idea of nesting and learning how to nest things and expand them, that has been really helpful. And because ultimately what it comes down to is that it costs money to buy that piece of wood. And when you, as a designer, what you have to think about is that you're buying a whole piece of wood. You have to buy the whole 10 by 48 thing, or whatever the dimension is that you set. And then once you buy it, any fabrication that happens after that, and any waste, you paid for the waste, but if you can't reuse it, it just gets recycled. So you really have to think about, how can I use the most out of that material? And it's led to this really interesting architecture of optimization and efficiency that we're constantly talking about. So I had mentioned these tests that we were doing. We've gotten really involved in testing, and I never expected this to happen, but because of our relationship with some of the different universities in OSU, specifically, who's interested in doing a fire testing lab, we started work on a facility that's just for testing fire. And we did not make it out of mass timber, because that would be just a little too risky. But it is directly adjacent to the Wood Products Lab, which was a building designed by Michael Green for OSU. And we're the small little building over here to the right. So good things are going to come out of this small little facility. So I'll show just a couple images of the labs that we're doing because they're interesting. But as a result of our interest in all these other things, we started really focusing on how to fire test and structural test and acoustic test. The other lab that was mentioned is U of O. There's a Terminal 2 site at the Port of Portland that they're going to be working on a mass timber innovation hub. And so part of that will be an acoustic design facility where we're creating 2 simulated, you could almost imagine these as like apartments above and below in this little chamber, and testing it. And that building we can do out of mass timber. Because it's kind of, we're working with the idea that you come up with a panel that you can cut once and then put on a truck in the same dimension and then tilt the building up. And it's kind of like the Butler building version of utilizing wood. I think that as we're doing all this work, I'm always looking at, and I Google this periodically, how many mills have closed this year. And in this last year, I think there's been, in Oregon and Idaho, probably 8 mills And I always find it interesting that the reasons that they're closing is that it's unsustainable for operation. Drug-free workforce is hard to come by, housing shortages, and in a strange way, a lot of the things that are the reasons that the mills are closing are the reasons that we're trying to do the projects that we're doing. But one of the opportunities is that Timber Lab, which I will be able to show more about this probably in the future, is building a CLT fabrication facility. This is the picture of their plant in Portland that some of you probably visited, that we're going to be going into. And interestingly, I have not visited here, but I'm just going to throw this out. If anybody does know how to get a tour through, this is the Autovol plant in, I think it's in Boise, that is putting out affordable housing modules. And we're really interested in having the opportunity to do a project with them. But it's also a little bit terrifying that this photograph, there was like not a single person. I think it's probably just because it's the robots, but hopefully that's not the future. So I'll talk a little bit, and I know I feel like I've always started to talk a little bit, but I wanted to talk just about a few of our like actual buildings and walk through 2 projects that, or 3 projects that are just like how we think about using the material aside from all the research and testing. And I think what we've discovered is that there was early on this idea that mass timber was just like either you do an all wood building or just like forget about it. And then we started realizing that we're like, yeah, but every building that we do has a concrete slab because you got to put it somewhere. And then as we started working in places like LA, they're like, well, I don't know if I feel comfortable with an all wood building. So you're like, well, what if we just use wood as the floor deck? And over probably 5 years, we've ended up doing lots of different buildings, and I would say probably at least half of them are a mix of trying to integrate mass timber into the building in a way that is appropriate, and it starts to make you realize that, or at least for myself, that the timber is not just a solution, but it's just like another one of the building materials that you're using. And you can build all these interesting things out of it, but you also are mixing it with steel, concrete, and the finishes, etc. So currently this is what is allowed in the US for the different scales of the buildings. So up to 270 feet tall, and you could probably go taller than that if you had a fire engineer and somebody that was interested. But we had to come up with a methodology for how we could figure out where the mass timber would fit into the project. And it really had to do with, do we need a flexible floor plate or not? Do we want a parking podium? Does parking play into it or not? And so we built a little spreadsheet for ourselves so that we could track through based on the size of the building and the kind of different programmatic pieces, what the best system would be. And currently, these are buildings that are all, with the exception of framework, and the different kind of scales of the buildings, and there's quite a range. It goes from 15,000 up to like, the Adidas project was like 400,000 square feet. So going into how we're using this and thinking about this, I'll share 3 projects, and I'll try to be brief here. I haven't really been paying attention at times, so I apologize if I'm just droning on about wood. But we wanted to do a renovation of this building and use CLT as a load-bearing window system. And we had the opportunity with the Nature Conservancy, who had their own forests, to really come up with a project that would take materials from different forests and integrate them into the building in different ways. So we had cedar siding that was used from one part of the state, juniper cladding that was used that was for restoring water and has started to show up a lot more in our work because it is invasive and removing it from the landscape really helps. In this case, the juniper, by using it for the project, returned over 700,000 gallons of water a year and brought back a spring that hadn't been on the area that we had done the harvesting since like the 1930s. And then just created a great space where we could experiment with, we used load-bearing windows, or a system where the actual windows were load-bearing. And just thinking about how we could also use different materials to create depth and changes in material. This is not about mass timber, but we were really interested in the idea of custom metal panels, and it pairs well with timber because it's light. So as a facade system, it's really helpful not to just load up brick or other heavy cladding systems onto the building. So I don't know if you took road trips or ever played this game, but I have a sister and we took long road trips and we would always play Connect the Dots. And I think this project was a point-supported tower, and I feel like this brought out like the puzzler in me, where it was like an obsession with connecting the dots, and metaphorically and like literally. So this is the Sandy Pine project. This is in for permit right now in Portland. It's utilizing the MPP deck for the floor system. And the idea with this project is that to make the timber efficient, or the overall cost of the project efficient, we wanted to remove the beams from the project. And that gave us a variety of benefits that I'll get into, which have to do with higher floor-to-floors within the same height. Also, this is, I don't expect you to read all this because I just pulled this out of one of our decks, but these were all the things that the point-supported system could do for us. But what was the main constraint is that you have a 10 by 16 grid that you're building with. And at 12 stories or higher, the columns start to get really large. And so you're designing a 10 by 16 space with maybe a 9-foot ceiling, and you have to think, if you've got 30 units on a floor, how do you do that? Before we got into the planning of the actual layout of the floor, we said, let's ignore that for a second, because how are we going to connect this building to the landscape and Portland as a place? In the 1850s, before Portland was even a city, there was this walking path that I've highlighted in magenta here, that was an indigenous path just to walk from the Columbia River, which is on the north side of the page, to the Willamette, which is on the south. And that walkway, over time, became a connection point and a wagon road. And then that wagon road was the connection on the Oregon Trail that would come through Idaho and to points abroad. And in Portland, it turned into a boulevard. And then the site for this building was on that boulevard. And what was interesting to me is that the boulevard connected to the gorge and all of this amazing landscape upstream. And at a local level, we were connecting and cutting through the city grid. So it was this kind of unusual site where part of the site was nicked off by this trajectory of Sandy as it came through the site. So we came up with an idea that we're going to do a two-part building. The part that's addressing the street and the ground, which is demonstrated here by this big red square. And then highlighted here so you can kind of see what the finished product ended up at the street level, with some housing and some live workspaces. I won't get into the details just for time. And then the upper part of it, which was the idea that we were going to create the shape of the building, which, mind you, we're still functioning within this connect the dots world, trying to ignore that for a second as we come up with the idea, that connects with the alignment of Sandy. And it also has these benefits where you start to look out of any individual unit, you're always seeing out to a natural feature in the landscape, whether it's Forest Park on one direction, or Mount Hood, or Mount St. Helens, or these different natural things. Because we're 12 stories up, we're going to see that landscape in the distance. So we were rooting and connecting the building at the base to the city grid and then to the views above. And then we did the point-supported layout with that shape, and we did have to fuss around with it because of this kind of angle, but we came up with a fairly straightforward system that allowed us to put the primary structural column right at, or the core for the elevators right at the knuckle where those things all came together, and then we had, surprisingly, only 2 stair cores out at the ends to help with the structural stability. And really worked with this idea that we're basically creating a building where you're just among this forest of columns. And then we did the floor layout. I wouldn't recommend this shape for a floor layout in a point-supported tower, but it turned out pretty cool. It was just not super efficient to think through it. And we realized in the process as well that when we were going through with the contractors and measuring how much wood there was and the volume of wood, that very small tweaks to the columns wouldn't really change the volume of wood that we were using, even though there were like some 300 or 400 columns per floor or something. It was this really large number. But then if we would change the thickness of the deck by like 2 inches, it would have this massive impact on the volume of wood. And so we started to realize that most of the wood volume for this project was in the floor slabs, which was really important because we were trying to decide, and this was a strange trade-off that you get into with mass timber, where structurally it would be fine if we would have a 5-ply assembly, but from a fire perspective, if you burn through in 2 hours, like if you're thinking about from a code perspective, you have a 2-hour protection rating that you have to have, the floor has to meet, that it's going to burn 4 of those inches away or 3.5 of those inches away, and you're only going to have one set of 2x8 boards going in one direction, and it's not enough, so you have to add another 2 layers based on the way the panels are built to get to a 7-layer panel. And that is a huge cost issue, as I was describing, with 60% of the floor. So we went to the engineers at OSU and we worked with some folks that we know and said, let's test these panels. And then let's test it with mass plywood and see how thin of a mass plywood deck that we could get. So this is showing some of the CLT testing, and we may be trying to get somebody to manufacture us a custom panel. They always love that when you ask that. Can you just change your entire setup for your whole manufacturing facility to take one lamella off of this panel? Or we could also look at mass plywood, which, as I was saying, is just this accumulation of simple layers. And then we're also looking at just different ways that, not necessarily completely going the auto wall route, but thinking about the different pieces that we can bring in that are prefabricated. And then there was the exercise of designing the units, and I feel like we kind of did it. There was columns where you would not feel like there was a column in your way, and you could see the scale of the actual space. And then there was a taller ceiling because we had gotten rid of the beams, which this is a version that is a little outdated where there are 2 beams, because we were like, well, what if we just put in 2 beams to hold up a balcony and then be fine? And the owner was like, just stay pure with the concept, so we took those out. But I think it's, from a housing standpoint, the volume or the height that you get, you can have probably, you know, a beam at this scale would probably be at least 18 inches to 2 feet and would start to break up the rooms. So anyway, the free height is over 9 feet tall. I think in these it's a little 9.5. And then we were in a tight zone with a slope site, so it meant that the building could only be so tall and we had to fight for every inch. And not having those beams and having the 6-inch floor slab was just an amazing opportunity. And then, of course, we had to test mass plywood for acoustics because we didn't have that information yet. So hopefully this project will start construction in the near future in Portland. And then the last one, which I'll end on, is playing around. And this is kind of like the opposite end, I think, of a lot of the work that Lever's done, where this building is really for a hotel. And we didn't quite realize it in talking with the owner up front what his ambitions were. And it's been under construction now. When we started the project, it was going to be the first mass plywood building. There have since been like lots of mass plywood buildings built. But the reason that there's so much time that's been spent on it really doesn't have to do with the timber, but they're building a hotel in the Arts District that's just really fascinating. And it's connected to all these different things around Alberta Street, which is a really lively street in Portland. Hot places that you can go in the middle of the winter. I'm thinking of Marrakesh, and we're like, oh my God, this has nothing to do with Portland. And it's water, like how can you mix water with a mass timber building? And then he's like, well, it's just like the one pool on the main level, but we can put the other 5 pools in the basement. So we're like, oh my gosh, this is getting exciting. But we did take the challenge seriously and looked at the different ideas about using balconies, which he wanted to make sure that every unit in the building had a balcony. And we exposed the mass timber in the ceilings, but we came up with a system that would basically allow us to, again, get rid of the columns, which I'm not opposed to columns, but we were trying to get quite a few units into a tight site. And so we came up with a system that we call the plate and panel system. We're using low carbon concrete on the first 2 floors for the areas where there's lots of water. And this is, I don't know if this reads very well on this scale. And then the upper 3 or 3.5 floors, I guess you could say, are all just mass timber decks over light gauge construction. And I'll kind of split through these, but you can get an idea of the pools that are in the bottom that are starting to show up, and there's a solarium with a pool on the top. And the idea was that this plan is very kind of rigid in the layout, where you always are bearing the mass ply panel on the partee or the partition wall between the units. So it's really, I want to call it a house of cards, but I feel like that's not the right thematic term for this. But the idea being that you just run mass ply panels across, and it gives you the same benefits that the point-supported system does at a smaller scale, which is that you get the taller floor-to-ceiling heights. And so this is like probably about a year ago, they started tilting up the panels, or tilting up the walls and dropping the panels. And much like all of the other buildings that we've done, the mass plywood actually, after you get it out to the job site, ends up being like the most simplistic part of the job, which is great. The units have a great view of some of the adjacent neighborhoods. And then this is just like the hotel units, just a few views of the hotel units. And I'm really looking forward, this is like, I think the photograph of the lamp in it was taken like a week or 2 ago, where they're almost finished and we're all really excited about it. But the idea just being that you can also, in that same height, have a small mezzanine level bed loft that you only need like a 6-inch floor to support, which is really cool. And just thin up the actual use. So, and then who doesn't need hot yoga? I shouldn't be facetious, it's going to be really great. And then this is not mass timber, but it's just cool. It turned out kind of like the rendering, so we're like, oh my gosh. And then if you're in Portland in about 3 months and are really interested, the idea of the spa, it's like really coming together. And I thought I would just throw this in there. It has nothing to do with timber, but you know, you can't use timber everywhere. So. All right, well, I'll stop there. It was really great sharing a little bit of work. I don't know that I've tied this in a neat and tidy bow, but I will say that I was mentioning those Sears Roebuck homes that were being shipped around the country in the early 1900s. And I don't know if this really reads well. It's kind of this funny clipping. But I loved it that it was like, build your home the skyscraper way. It's like, I don't know what that even really means. But if you look closely at the zoomed in pieces, it basically is showing that the same things that are being used to build the skyscraper are the same pieces of wood that are coming out of that you can use to build your home with. And I think that this, in a weird way, still makes a lot of sense, and that material has that much flexibility and range that it can be in all of these different types of construction, and it will be the joy of my life to be trying to figure out these systems as long as I live, so I'm excited about that. And if you were reading the news, turns out that Japan just launched the first wood satellite into space a couple days ago. So wood's going to the metaverse now. So anyway, it's nice talking with you this evening, and I think I'll stop there.
Further questions? Raise hands. Let's try with the microphone.
Okay, I don't know if mine's screen.
No, because for Boise, it's not here.
Oh, they can hear it, but it's not going to hear it? No. I don't know if it's working. Okay, you mentioned that some of your buildings have helped like contribute to code and how lumber has been like accounted for in code in Portland and Oregon and elsewhere. I can imagine that was at one point the most difficult part of working with wood. What is currently, in your mind, the most difficult part about working with wood?
Well, I would say that the building code process it's like that's an ever-evolving animal that will continue to be difficult to get people comfortable with mass timber, so it's not in any sense like resolved per se. And I know that lots of places are still trying to adopt the mass timber building code, and there's a lot of jurisdictions, like I think New York has started to be more interested in mass timber, and there's construction happening with that. But New York has obviously been one of the most concerned about the use of wood just because of the density of people and the scale at which buildings happen there. So that does take a lot of work. So right now, I guess the question is like, what am I thinking about most with wood, or what's the most difficult part of working with wood?
Yeah, the latter.
I think that it's an infinitely interesting material, and it requires an intense amount of focus to pick which part of it that you're going to focus on. And that is like the challenge, I think, right now, which sounds like a weird answer maybe, but we are trying to do projects. There is the forest, and forest politics and industry politics are incredibly complicated. Forest ecosystems are incredibly complicated, and there is very rarely like a black and white answer on complicated questions like that. And so I think that is probably the most difficult part of working with wood as a structural material at this scale, is just like trying to navigate and figure out how to do the right thing, I guess, for lack of a better way of putting it, and thinking about the way that resources were extracted and like trying not to just view this as an infinitely abundant resource that will always exist forever and that I don't have to think about how I'm using it. I can just like buy it at the store and put it in the building. So trying to really think about that as the hardest part.
Hi. I actually was part of the team that met with you last year, and this question, like your answer to this question, kind of ended exactly where I wanted to go, which was like one of the main takeaways when we met was how you source wood and what you guys kind of found when you looked into like, but you talked about it earlier, looking upstream, like,
Yeah.
where does this wood come from? Can I point to the tree that like
Right.
was cut down right here in this building now?
There's so much in that question, and in some cases the answer is like, yes, of course, I cut that cherry tree and I made it into a bench, and the bench is right over there. And then as the building gets larger and the systems get more complex, and you start talking with lots of different mills that have lots of different processes for how they do things, or groups that may track where they get their materials from and have lots of different landowners that they're getting lots of different material from. There's a whole bunch of that question that's really complicated that we're still trying to come to terms with. One is that sometimes it's very easy if you have a landowner that's like, I have X amount of juniper siding and I'm gonna go get this wood, and it grew over here. I used my horse or non-invasive kind of extraction methodologies to like get this out, and like you can see it, it's right there. And then there are other places where it's like, to get the volume of wood that we need, we might have to be getting wood from a mill that has 10 different landowners that's coming, they have to sort it differently. And so we're really focused on that question around sourcing and trying to ask the question in a way that it doesn't, that it gets to the answer that we're looking for, which sometimes you don't know what the actual question is that you're asking. So if I knew where my tree came from, then what, you know? So we're like, well, what I'm hoping that it means is that I could go back to that landscape and spend time in it, and I might not really care that that tree was taken from the landscape. And then in other cases, like clear cutting, I've heard often that clear cutting is a necessity for the industry to survive in certain situations. And so there's this like really complicated balance that I am in no way an expert about, but that we are what I do care about is, to the greatest extent possible, being able to draw that thread that you're describing, which is like this tree, that mill, this building. And I think that the importance of it for me is that trees are living organisms, and I'm not getting too far out right here, but trees are living organisms, and I think that the reason that people are so fascinated by them is that they have the imprint of their life, and they have this like lineage that like you can see every single piece of it has some sort of texture that came from its place. And I want to be able to make sure that that continues to happen in a healthy, exciting way. Anyway, but I think that's going to be like a lifelong struggle to try and really understand that, and to ask the right questions and not ask a question that makes somebody go off on this heroic goal to like document tons of stuff, and then the person that gets the information is like, oh, cool. So, anyway. Yes?
So,
Oh.
sorry.
I think
I
it's
don't know if people can hear me, I
Sure,
know
let me
that,
begin.
but, so we have a question that's come in the chat via Zoom, and it's from one of our faculty, Carolina, and she is asking, in the last 2 projects that you showed, what are the lateral force resisting seismic systems?
Yes.
Example cores, approaches, materials used. I don't know if
Yes.
everybody in the room heard me.
In both of them, we used a concrete core. So that was the primary system. In the Cascada project, which is the plate and panel, I'll call it, system, the walls are load bearing, and they have some shear. We used a shear panel in the actual bearing wall system, so that some of those partition walls are shear, and then there's a concrete, I think 2 concrete cores. And then for Sandy Pine, we looked at, that's the tall point-supported building, we looked at doing brace frames, which are like the steel frames, versus the concrete cores. And I think that concrete is kind of a necessity at this scale. There is no like wood version of this that's going to work in a high seismic zone right now. And I think we opted for the concrete because it was more efficient and it wouldn't introduce yet another construction trade into the mix, and have the other part of it, which is sometimes that you get welding on site adjacent to wood things. So I think in that case we opted for the concrete core.
Other questions?
Oh, you're welcome.
I think you have kind of a fascinating role in the firm there. And I'm curious if you can talk a little bit about how your position works in relationship to the rest of what the firm is doing, as people here with potential different careers.
Yeah. I guess so I started, I graduated from the University of Oregon in like 1999, and I'm not going to be, I was born in 1960. This is getting to a point, but I started with an interest in construction, and I was in Oregon, and so I started doing work on just housing, like building small residential structures. And then I got my architecture degree and started practicing architecture in Portland, and at the time it was like renovating old wood buildings. And then that led into renovating larger and larger buildings, and then into the work that I'm doing now. So over that period of time, I think the role that I was really achieving was to like take this idea that we had come up with as a firm, and then make sure that you could go through all the permutations of it to figure out how to execute it and get it built. And so that's like the #1 role I think I've been at Lever, is just to try and be that thread of like the blue sky idea to like the pragmatic, like how do I get it built? And then with that, I've just been absorbing kind of construction and weird facts, and I have a whole other set of interests that are related and get tied back into this. But I didn't, like, if you would have asked me when I graduated, like, what do you want to be kind of thing, or even like 10 years ago, what do you think your involvement in this mass timber project is going to imply for your future? I don't think I could actually answer that. And like looking ahead, things are changing so rapidly and the industry is changing so rapidly that it's like the role is just like be present and like be interested in what you're doing and talk with the other people that are around you and share that information that you've learned. And then the topics are sometimes, yeah, fill in the topic, you know.
Sorry, but we have another Zoom question.
Oh, yeah.
And then maybe we have time for one more after that, if anybody does. But, so what is happening with the CLT with cable systems as a seismic approach tested for framework?
Yes, so the project was put into the NEAR shape table for the National Science Test. That testing ended in May. Framework was not able to be built and is just sitting there. The whole permit set is still ready in case you know anybody that needs it. But then currently what we're doing is there's a small scale building in Portland at 3 stories that we have a design for the rocking wall in. And then there are a lot of people all around the world that are kind of interested in the technology and different people that we've been talking to, but we do not have the first like building project yet to incorporate that. But I think what's really interesting about it is that it can go anywhere where there's a high seismic zone, that system can be utilized. And now several different construction companies have fabricated all the pieces and kind of know what it takes to construct it. And so that information is kind of sitting there ready to be used.
Follow up.
Yes.
What's the max height you are thinking for the framework system?
I think that we could, well, oh boy, math. I'll just say that like it's taller than framework, and I don't know if we can go the whole 280 feet. That would be a design challenge. So yeah, probably I would say it would probably be efficient up to like 15 to 18 stories, depending on the floor height. And if it had an engineer here, they'd be like, actually, somebody already did it, it's 35 stories.
All right, we have time for one last question. All right, okay.
Start and end.
I'm willing to yell too. I thought your brief mention of wood chips was really interesting, and that construction process is something I haven't looked into very much. So I guess my question is, have you looked into it? And if so, is there any like cool facts or interesting like takeaways that you didn't expect to see?
You mean like the OSB type material, or?
No.
It's like the oriented strand board where you're like taking lots of stuff and putting it all together with adhesives, or?
Not particularly. I guess the wooden, I'm not sure if I was not clear. The wooden ship construction.
Oh.
Yeah, you had like the wooden ribs of a ship at one point.
I think that like we're often trying to align like 3 things with projects, and that is just sitting there waiting to be inserted as an idea. Because there is like this really amazing history of like building the hull of a ship, and that was all done by hand. And now, also very similarly to this discussion about like Japanese joinery and hinoki and all that, there's all of these old friction fit and different joineries that were really laborious and took a lot of time to create, are becoming relatively easy to do digitally, and then CNC route them. And so often we're trying to, knowing that that's a potential idea, trying to come up with what's the project that we could use that with, but then that use of that material somehow ties back to the idea of creating that transformational experience for whoever's doing it. And I think I'm excited to work on something like that and do that. We definitely in the US have been really focused on just this because there is a lot of competition with like Europe being able, they've been doing, their mills are much more sophisticated and they've had more investment in that technology, and the US is kind of catching up, which means our approach is much more about how optimized can you get, like do the most with the least, like because it has to do with cost and all that kind of fabrication competition, I guess you could say. But it's just really interesting, like we're always trying to tie all those things together. Like what's the best way to do it? What's the right fit for the site? Who's it for? So, yeah. It's really exciting. I don't want to, I mean, I keep saying exciting, but it is really, it's kind of infinite at some point.
Oh, it was great.
Great.
Thank you very much. No, really great lecture. Thank you very much again, Jonathan. I think you showed us really how research and design are one thing. You know, it's not just, okay, this is the research and then, yeah, we make a design later, or the other way around. So that was really beneficial, especially for our students. We have a design studio, which is at the third year, which is focused on CLT. Yeah, it's 354, right? So I hope you got inspiration from, you know, the very interesting, let's say, things that Jonathan shared with us today. Yeah, concerning the lecture series, you also proved the sort of connection between shelter and high rise. And you started with, you know, this your lecture with these drawings from birds, like Andrew.
Yeah.
That one. It's Boy Scout also. It's kind of related to this language.
Yeah.
So very, let's say, elementary, primitive, let's say, forms of tectonic with wood, and then you end up, you know, doing like 30-story high and towers, and that's great. That means that the two things share the same history, and so every time that you design a new thing and make research, you relate to that tradition, right? So that was really great. This is also why I think it was a really great final contribution for this lecture series about shelter and pedagogy, right? So the way we share the knowledge and the way we talk about and let's also instruct or educate, you know, our students on our side about wood. So unfortunately, this is, as I say, it's the last of our let's say, lectures for this series, for this fall semester. And so it's time, I'll say, also from the side of Amy and I, to make some thank you very much for participating to this very successful series. We would like to thank all the faculty for their contribution to this lecture series. In particular, we would like to thank Randy Tidd, our chair, for continuous support, and Scott Lawrence for helping us, you know, for developing this series as well. And I would like to thank especially all the students who participated with a lot of questions and for coming here and sharing your thoughts and also your willing to learn architecture more and more. Thank you very much.